actually sharing the same system that serves both our residential customers, hence many miles of lines out in the communities with a system that serves the refinery. And as part of that project, on Friday, prior to October the 11th, which I believe was October 8th or so, we conducted some wiring changes within the substation in preparation for work that was going to be conducted the following week. And that wiring changes was really an upgrade in our protection scheme as part of this sort of multi-year and multi-million dollar upgrade to the refrigerator system. There was an issue in how that modification occurred, and that issue didn't manifest itself until the load coming out of the substation, being served by the system in the substation, rose to a certain level, which we didn't see until Tuesday morning, after Columbus Day weekend, which was a long holiday weekend. And when that load increased and was exacerbated by the fact that we isolated a portion of the substation to do the work that we intended to do on Tuesday, it triggered this relay or this protective device because it went above a certain load value, and it triggered that device to operate properly as a result of the wiring issue that was performed on Friday. And as such, we lost the entire system serving 100,000 customers as well as the refinery. So this was an outage to the refinery, as I defined earlier in the presentation. We restored power to the refinery within 28 minutes, but by then it was too late. It impacted their operations clearly, and then within another 40 minutes or so, we were able to progressively restore power to our remaining customers by 7 a.m. That morning. So that's effectively what occurred on Tuesday. Now, as soon as this interruption occurred, we did have personnel working in the substation for their safety. We were not able to re-energize the station right away. We wanted to make sure that they were cleared of any potential safety hazards. We also wanted to inspect the rack within the substation to see if we could identify the source of the fault. So there was an inspection that was conducted such that really within about 27 minutes, 28 minutes or so, we were able to begin restoring service. We've halted all work within the substation ever since Tuesday. We were about 90% complete with this multi-year effort that I was referencing, but we want to take a step back and make sure we understand specifically what led to the wiring issue in the first place, what our current protocols dictate, and do they need to be reviewed? Is there a different way to approach the remaining work going forward? And just as importantly, we wanted to engage PBF Energy to begin to determine what protocols we should use to proactively communicate and notify them ahead of time, ahead of us doing this line work, so that they could understand the potential impacts that these efforts could have on their refinery. None of these, both the September, October maintenance activities, none of these required an outage to a customer. So in both of these instances, they were accidental outages. They weren't planned, if you will, maintenance outages. Okay? We move on to the next slide. So how we would like to proceed in avoiding similar incidences in the future. So first off, we have a significant amount of work that we're doing both at the refrigerator substation, but also in the community at large, with all of the lines that are emanating from all the substations feeding into our customers' homes and commercial locations. And so that work continues. That work has not been halted. The only work that has been halted until we have a better sense as to how to best proceed is the work within Fraser. We have about 16 months worth of work completed there. Once that work is going to be completed, it will continue to significantly enhance the reliability of service being provided by that substation. It provides additional redundancy, and it provides an improved protection scheme that will avoid a number of potential outages in the future. So that work eventually needs to continue. We'd like to coordinate that work with the refinery, given the impacts that it could have on the refinery. Secondly, and Jeff touched on this, ultimately, our recommendation has been for a number of years working with refineries' predecessors to develop a 220 kV dedicated service to the refinery. And so Jeff and his team have been working with us for the past several days and beginning to formulate what that would look like. This is a very complex service and set of investments that we would have to make. And there are permitting and licensing implications as well. But more importantly, there's some technical complexities here that we're going to have to think through, but it is doable, and it is in fact the best way to ultimately serve a refinery type of operation. That being said, this is a longer-term solution. This is not going to happen in the course of the next 2 to 3 years. It is a longer-term solution. Hence, we are also in parallel working very proactively with PBF Energy to explore short-term and medium-term solutions that may not remove the entire risk, but certainly will help mitigate in a more material way some of the exposures that they currently still have. And we'd also like to continue supporting PBF Energy in any assessments that of their own internal operations that may help them even better ride through some of the disturbances that they are feeling on their side of the refinery. There may be things that could be explored there. So those are the steps that we've identified in addition to all the work that we are doing in the community as well as in Refinery. The next couple of slides are really a recap, and this is again addressing an outage, a maintenance outage, which is an outage that we perform based on planned work, and we notify customers. So none of these were outages that they were planned, or we been notified because they were really a reaction to an event. None of this work required an outage, but when it does require an outage, and that typically occurs at lower voltages, we do have a notification process. We will notify the city of Torrance, city staff, as well as our customers on the day of the outage. We call the customers to validate that the outage is going to take place. In some instances, it's the minority of cases, but there are instances where we can schedule the outage because of some weather events or because of some heating and high temperatures, and we wouldn't want to disrupt power to our customers. So there's a whole process, if you will, that is available online whereby customers can get information, and again, we proactively notify them. Repair outages, we sort of briefly describe how things occur there, and these are reactions to events that are uncontrolled, if you will, and there's a variety of sources of these types of events that are listed here. The last slide is simply a description, a step-by-step description of how to actually work through the outage center on our website that allows customers to enter their outage number, if it's a maintenance, a planned outage, if you will, to be able to get an update on the status of that outage. With that, I'm closed. Thank you.
I think I have a question from Council Member for $20. I have a question for you. Who was back around? We're ready. Yeah, we have communication on City, so we're just taking care. Councilmember Goodrich.
First, I just wanted to start off and thank you and your company. Since the turnover in operations from the previous company to yours, I have seen an increase in transparency and communication. And although we still have many issues to work out ahead of us, particularly in regards to the NHF, I appreciate your efforts. Number two, I was wondering if you could give us an update on the status of the worker that was injured during this incident.
Absolutely. He was released from the hospital, returned to work the next day.
Great. Wanted to know a little bit about the standard practice of other refineries in regards to their power capabilities, specifically cogeneration power that they generate on site, backup power, things that other refineries might do to prevent these types of interruptions.
Sure, I'll have Steve join me. He may be able to add some more color. I can speak. I've been in business around 30 years, and in a number of refineries. I use the analogy a lot to what is now the Phillips 66 refinery in Wilmington, because both Steve and I work there. It has a cogen plant. I think one of the things to keep in mind is just because a refinery has a cogen, in some respects, regardless of its size of that cogeneration unit, it does not necessarily isolate you from the Southern California Edison grid. Just the way they are configured and the fact that you have to maintain those pieces of equipment as well, interruptions on the Southern California Edison grid can still affect and bring down the refinery even with the cogen. So that's one thing. Second thing is, just like with the project we're proposing now, it involves permitting, essentially a new power plant in Southern California. And so it is not, a fast solution that I think Paul and I would put in the category of short-term, fixes. And we still think connecting to a 220 system versus doing a cogen provides much more reliability, to the refinery long-term. I don't know if you want to add anything.
Well, every refinery is different. We actually have cogen. Some have cogen partial, load to reduce their electrical bills. We have that by working with Wilmington. That's what they did, and I have full cogen. Some, the only one I'm really familiar with is the old BP Arco. They have Sempra Energy, they have a 400 megawatt plant. What I kind of see is that if you have a large cogen pump, I think you tie in at the high voltage. I think it's more the high voltage that you tie in because it's a necessity. I don't know if you agree with that, than the fact that you have a cogen. Because you're still tied to a big system, that something big happens in that system and impact. Inside the refinery, we usually have a combination of different measures to try to keep critical utilities running. We have backup power for our instrumentation, for our control rooms, for our lighting, to keep some of the boilers and the air compressors. That's what we try to do, because that allows you to have steam for your critical safety systems, and also expedite stabilizing the units and restarting.
With the cogeneration, I'm assuming here that if you were to increase those capabilities, as you say, that may not solve the problem, but that would also introduce increased air pollution locally?
It would be a new emission source.
The new systems that are being proposed, these new lines coming in here, are those meant to be redundant systems or simply increase the reliability?
We envision it being two lines dedicated to the connection to the 220 system, so they in themselves would be redundant. Whether, I don't know the ability of using the existing system in as well, or whether you could switch fast enough, I don't know if that would make a difference, but we would put redundant lines in if we connected to the 220 system.
The whole idea of the 220 kV dedicated service is really the dedicated service. So what we're trying to do is to remove the refinery from sharing service with other customers. And the point being is other customers means other lines with hundreds of miles of exposure, with poles and towers and transformers and vaults and all the things that can go wrong by the multitude of the sort of the spider web, if you will. We're trying to limit that exposure to the refinery of many of those other lines. It's really the dedicated service that is the point that we're making. Ultimately, the 220 kV would have to be stepped down to 66, stepped down to 12 kV. So they're going to get the same service that they're getting today in the voltage class, but it's going to be dedicated to that. They won't be sharing systems with other lines. Does that help?
Understand. Some questions for Edison now here. So it seems like a good portion of these power outages are being caused by heavy fog, arc flashes. What can you tell me about Edison's maintenance practices in regards specifically to washing, and what the maintenance cycle is to prevent this arcing from happening, and was this cycle adhered to in these cases?
Yeah. So several things. One, we have we are required by the regulators, CalISO in our case, as well as the CPUC, to conduct annual patrols of our lines. We conduct many more patrols than that during the year, so we exceed those requirements, specifically in areas such as coastal areas where